Hello everyone, welcome to DCC NIT Agartala. Today I'll be discussing the problem C. Count the number of beautiful subarrays from LeetCode weekly contest 336. So the problem statement states that we are given a zero indexed integer array nums. In one operation, we can choose two different indices I and j, and we can choose a non-negative integer k such that kth bit in the binary representation of nums of I and nums of j is 1, and then we can subtract 2 to the power k from nums 1 and nums I and nums j. Okay, a subarray is beautiful if it is possible to make all of its element equal to 0 after applying the above operation any number of times. Return the number of beautiful subarrays in the array nums. A subarray is a contiguous non-empty sub. Okay, now first of all, what we are asked to do in this problem statement is that just take the example 43124. Okay, so we have 43124. So subarray is beautiful if we can make all the elements 0 by applying the operation, and the operation is that from the subarray we choose two indices I and j, which have a common kth bit, and we subtract 2 to the power k from both the ith and jth numbers, which means that we remove the kth bit. That is, we remove the kth bit. For example, in this subarray, this is a beautiful subarray. So in this subarray, we have 3 is 0011 and 1 is 0001, and then 2 we have 0010. In this case, first we'll choose the first bit and we'll remove uh, from 3 and 1 we can remove this first bit by subtracting 2 to the power 0, that is 1. So now this will become 0010 0000. This is already 0, and then again we'll have 0010, and once again we'll choose this bit and this bit, and we'll subtract 2 to the power 1 from these two numbers, and we'll again get three zeros. All the numbers will be turned to 0. So one observation that we can make is that for any subarray, suppose 4 3 and 1. Okay, so 4 is 0, no sorry, 4 is 0 1 0 0, and then 3 is 0 0 1, oh, 0 0 1 and 1 and 1. Okay, so 1 is 0 0 0 1. So this is not a beautiful subarray because we need two indexes I and j which have a common kth bit so that we can remove it. But in this case we can remove these two bits, that is these two ones, but this one doesn't have its pair and this one doesn't have its pair. So this subarray is not beautiful because the elements cannot be reduced to 0. Now this question, we'll be solving this question with zor, with the help of zor. I'll explain you how. Let me first erase all of this. Okay, now, so our array was 4 3 1 2 and 4. This subarray was a beautiful subarray. So in this case, if we take 3 zor 1 zor 2, what will I get? So if we, for better understanding, we can do it like this: 0 and 1, 0 0 1 0. We have two ones, so zor of 1 and 1 is 0, zor of 0 0 is 0, and zor of 0 1 or 0 1 or 1 and 0 is 1. So in this case, zor of 1 and 1 is 0, and this is also 0, and again, so we'll have a 0. So basically we need to find the subarrays with zor equals to 0. So now how do we do this? For this, let me again erase this. for this, what we can do with that? Let's write this very first. Okay. For this, we'll keep a variable zor, and I'll iterate through this array, and I'll also have a map. Okay. Now I'll check. Uh, I'll initialize my zor with 0. Now, for in when I come across 4, I start my iteration, and the first element I get is 4. So zor will be 0 zor 4, which will be equals to 4. Now I'll check with the map. Do I have any subarray or any prefix subarray which has zor equals to 4? In this case, I don't have, so I'll put 4 and I'll put a 1 here. Now I'll move to 3. Now my zor becomes 4 zor 3. 4 zor 3 is 7. Now I'll check with the map. Do I have a 7? No, I don't have a 7, so I'll put a 7 and a 1 here. Then I'll come to 1 and my zor will become 6. Once again, I don't have a 6, so I'll put 6 comma 1 here. Then I come to 2, and in now the zor will be 6 zor 2, which is equals to 4. Now, do I have a 4 here? Yes, I have a 4 here. Now what does this mean? This zor equals to 4 is up to this place, and this 4, that is the 4 that is in the map, it came from this place, which means that I have a subarray, prefix subarray, which had zor equals to 4. Now, uh, if you don't know, suppose this is our subarray, and the total zor is x, suppose, and the zor up to this is y, then the zor of this will be x zor y. So that's why, since our zor up to here is 4, now I check with the map. If I have already come across any subarray which has zor equals to 4, it means that the zor of this subarray, that is after this 4, the zor of this subarray up to this point, here I come across 1 4, here I come across 1 4. So the zor of the elements in between these two indexes will be 0. So here, since I have got a 4, now I'll keep my answer is initially 0. As I come across 4, I'll add all the number of indexes that had come before this index and had zor equals to 4. So in this case it's 1, so I'll add a 1 here, and I'll increment my 4 the you know now I've come across two subarrays which have zor equals to 4, so I'll increment this to 2. Now I'll move ahead, and in this case I'll get a 4. Now I had zor 4, now I again have a number 4, so 4 zor 4 is how much? 0. So now I'll check with the map. I don't have any 0 yet. Okay, but we had to find subarrays which had zor equals to 0, and this whole array has zor equals to 0, which means that this complete array is also a beautiful array. So for this case, this could give us an error, because if we check with the map, we don't have any 0 yet. So for this, when we initialize the map, before iterating, we'll put 0 comma 1 in the map. Okay. So now I check with the map. I have a 1, so I'll add it to my answer. So I'm adding this 1, and I'll put 0 comma 2. Now I'm done with the iteration, and my answer is 1 plus 1, that is 2. So let's code this. So this is the question itself. First we'll initialize an answer, and then we'll initialize a map, tree map of long. In the map I'll put a 0 comma 1, and then I'll initialize a variable zor, which will initially be 0. And then I'll start iterating in the map. Okay, first I'll update my zor value, zor really. Now if I'll check with the map, now if map contains my zor, then I'll add it to my answer. and if not, then I'll continue, and each time I'll update the map. Okay, so map dot put zor. It can be the case that the map doesn't contain our zor yet, so I'll use this get or default zor. This is the this is the value we are searching for, and if the map doesn't contain the value, it will return me this 0. And whatever it returns, I'll increment it and again put it back in the map, and I'll return the answer here. This should work. Let's see. This is the example test cases. The internet is a bit slow. Let's copy this. We'll refresh the page once. See, by running this works. Okay, int cannot be converted to long. Okay, so we'll put a L here, which means that it's a 0 but in long format. Int cannot be converted to long once again, so we'll put one L here. Should work now. Yes. It's giving 2 and 0. 2 and 0. Let's see, this gets accepted. Yes, it did get accepted. The brute force approach for this would have been to check all the subarrays O of n square, but this would surely give a TLE because the constraints are 10 to the power 5. So we are using map to store the ZORs of the previous prefix subarrays. Okay, thank you.